Imagine waking up one day and realizing that the limits of the human body no longer apply to you. You can run faster than a car, lift objects 10 times your weight, and even control machines with your thoughts. Sounds like a superhero movie, right? Well, it's not. This is the real-world future of bionics, and it's already happening. The future of humanity isn't just about evolution, it's about upgrades. But is humanity ready for this revolution? Or are we about to step into a future we can't control? Bionics, the fusion of biology and technology, is changing the way we see human capability. For centuries, prosthetic limbs were simple wooden and metal attachments, serving as crude replacements for lost body parts. But today we have artificial limbs controlled by the brain, robotic exoskeletons that help paralyzed individuals walk, and even synthetic eyes that restore vision. But this is just the beginning. How far can we go? Will we use this technology to heal the disabled, or will we push human evolution into an entirely new era? Today we'll explore the past, present, and future of bionics, and what this means for humanity. To understand where we're going, we need to see where it all started. The first prosthetic limbs date back thousands of years. The ancient Egyptians used wooden toes and simple prosthetics to help injured warriors walk again. During the 16th century, mechanical prosthetics with metal hooks and wooden limbs became more common. However, these devices were rudimentary and offered limited functionality. It wasn't until the 20th century that prosthetics saw real advancements. With the rise of electronics and engineering, artificial limbs became more sophisticated. The invention of the myoelectric arm, which uses electrical signals from muscles to control movement, was a breakthrough, but even then they were still nowhere near replicating natural human motion. The real game changer came in the 21st century, when neuroscience and robotics merged, creating bionic limbs that could be controlled directly by the brain. So how do modern bionics actually work? Let's break it down. At the core of this technology are brain-computer interfaces, or BCIs. These interfaces allow the brain to communicate directly with machines. For example, let's say a person loses an arm. Traditional prosthetics might restore some basic movement, but a bionic arm can go beyond that. Electrodes placed on the remaining muscles, or even directly on nerves, can detect electrical signals from the brain. These signals are then translated into digital commands, allowing the artificial limb to move just like a real arm. Some advanced bionic limbs even provide sensory feedback, meaning the user can actually feel pressure, texture, and temperature through artificial sensors. But it's not just about limbs. Bionics is also restoring sight and hearing. The Argus 2, for example, is a bionic eye that helps blind individuals see. It works by using a small camera mounted on glasses, which sends signals to an implant in the retina. The brain then interprets these signals as images. Cochlear implants, on the other hand, bypass damaged parts of the ear and send electrical signals directly to the auditory nerve, allowing people with severe hearing loss to hear again. But what happens when we enhance these technologies beyond normal human limits? Imagine an eye that can see infrared light, or ears that can pick up ultrasonic frequencies. We wouldn't just be restoring lost senses, we'd be creating superhumans. The most exciting and controversial part of bionics is brain-computer interfaces. Scientists are now developing implants that allow direct communication between the brain and external devices. Neuralink, the company founded by Elon Musk, is leading this field. Their goal? To create a world where people can control computers, smartphones, and even other machines using only their thoughts. This technology has already shown promising results. Paralyzed patients have successfully moved robotic arms using only their minds. But the possibilities don't stop there. In the future, we could see memory enhancement implants, instant learning through neural downloads, and even direct mind-to-mind communication. If that sounds like science fiction, just remember that 20 years ago, the idea of a touchscreen smartphone was just as unthinkable. Despite these concerns, the future of bionics is inevitable. Scientists are currently working on artificial hearts that never fail, potentially eliminating heart disease. robotic exoskeletons that could make lifting heavy objects effortless, synthetic skin with built-in sensors that feel pain and temperature. Beyond that, we may see full-body enhancements, cybernetic brains, and even the merging of humans with AI. Bionics is changing the world in ways we never imagined, and this is just the beginning. If you're new here, don't forget to subscribe. Here, we dive into emerging technologies and major global events that everyone should know about, with real, authentic information.